I'm going to just go where we were before on the initialize. Okay. So, it initialized. Once it's initialized, when we were in control panel, if you remember, it comes back, and now it no longer says initialize, it says set zero gap.
Yes.
Right. We're measuring the two-plate model. I assume you guys have had some introduction to that, right? Whether it's viscosity or rheology, right? Top plate, lower plate. Distance is the key thing, right? So at the temperature, or just what we're going to do, we need to know where the zero gap is. One thing about this upper measuring system, though, if you notice it has a machine fit at the top. The coupling that it fits into, there's a collar. You can remove and raise the collar. On the measurement system itself, measure the machine fit, just press in there, lower the collar. That's all you need to do. There's a little index mark here. There's also a little index mark on the collar, right? See right there?
Yes.
Best is always to align these two index marks, right? And then lower the collar. It doesn't necessarily affect your data that much, right? But if you think about it, what we have here is really a sensor. It's a torque sensor, right? And so, like all analytical equipment, what we're going to do is we're going to test one. We need to know to make sure that whatever we measure is just for the sample. So when we start and stop this motor, there's an inertia to the motor, right? It has weight, and we're going to put a force on it, right? When we add the measuring system, now we have the inertia of the motor, plus we have the inertia of this measuring system, right?
Right.
So things we need to do is, first we're going to measure the inertia of the motor, then we'll measure the inertia of the measuring system in the motor, right?
Okay.
The software stores the inertia of the motor in here, right? If you have multiple measuring systems, it stores the inertia of the measuring system over here. On top of that, what we need to do once we do that, and the inertia is just start, stop, start, stop, start, stop. We need to do what's called a motor correction. You remember that the motor is floating in air on the air bearing. And so as it turns around, let's just say there's some 0 point. This is a circular disc. At some reference point, as it moves around, all these little micro torques being generated by the air flying through there might be slightly different per position, right? So once you're done measuring the inertia, you do what's called a motor correction, which is a baseline. We're going to take the baseline torques that it takes just to move the system around in air, right? So now we know inertia, so when we start moving, so much of that force is just to move the measuring systems. The extra torque is for the sample. And the second thing is once we're moving and we move around, if you think of doing a viscosity measurement where we're just rotating around, we probably want to at least do one full rotation or as much of one as we can. And it's going to average thousands of points all the way around there, right? But what the motor correction does is say, okay, we're going to take this baseline torque and we're going to subtract that, for each point along the way, right? We'll see what happens. Okay. So first thing we need to do though is let's put it down. When we measure those inertia and the motor correction, the best way to do that is to measure where you're going to measure your sample, right? Before I do that though, I'm going to pull this out. The motor, we don't want anything attached to it when you measure that inertia, okay? So what I'm going to do is, hey, we came into control panel, right? We opened up our software, came into control panel, we initialized it. We're ready to run for the day. Because this is the first time we're running this, I'm going to go to the service tab. And in the service tab, you'll notice that the top section is called inertia, right? Don't worry about the offsets. It's something you'll never have to do. First, I'm going to click on drive. This is going to measure the inertia of the drive. And what I do is I'll just click start at this point, okay? If you notice what happened is that the rotor moved around to a certain start point, and now what it's doing, it's really, if you focus right on that screw, you can see it. It's wiggling, right? We don't want to bump the bench too much because any force you put into the bench is a force that the motor can see, right? And so what's it doing? Start, stop, start, stop, start, stop, right? It's measuring through 300 points, what was in there, at a certain frequency range. You know, what sort of inertia does it take? And it's going to come up with an inertia correction value. When it comes back from being grayed out, then I know it's done. It takes it about 30 seconds to run through, right? The motor, the inertia for the motor gets stored on the instrument. So when it's done, I'll click OK. It takes it a little while to save this because it's actually communicating back and forth the instrument. We've done the motor inertia. How often do you need to do that? Typically tell people about once a year, right? When the instrument's new, maybe you do it after 6 months, right? Okay. Now we have.
What is the value you got of?
If you open it back up and hit drive, you can see the last value that was stored, right? So 0.07 millinewton meter second squared. Right? Now, I'll just hit cancel there, right, and redo it. I'm going to go back to the control panel, the front tab, right? This is where we actually make things move up and down. And I'm going to install the measuring system. I'll line up the index mark, put the collar down, right? And now I want to set the zero gap. I want to send it down to its, find out where the bottom is, right? So I'll hit zero gap. There's some position controls right here. This is the speed which is going to move down, raise up, everything. We'll get to that a little later. But I created a default one called USC1, so you can use that to start with. It should be good for what you're testing. Okay, so it's gone down and it says, hey, there's the 0 point, right? But that is the 0 point at this temperature, right? Okay, and right now, for what we're going to measure, the inertia and motor correction, I'm not too worried about temperature, right? I'm really just worried about collecting data on the measuring system. So, when it's done, it just moved back up. See that? It moved back up to the measuring position, 1 millimeter. Okay, so when we measure, we're going to measure with the hood down. That creates that nice environment I was talking about earlier, right? LTA hood, LTA plate, we get good temperature control there. That's typically where you would measure. That's typically where you should measure your inertia and do your motor correction. So it's at its gap. I'm going to come back to the service tab, and I'm going to click on measuring system, right? Now, this instrument does not necessarily know what measuring system you have installed on it, right? On our newer systems, they actually have a chip on the top of these measuring systems that it reads, okay? For your instrument, you only have one measuring system, so it's pretty easy to choose from the list. Right here, I'm not going to worry about changing the inertia right now. It's going to measure a frequency, it's about 10 hertz, 10 millirads. It's going to do about 300 of those measurements, so it's going to go very fast. Right? I'm going to choose, and I'm going to say, hey, we're going to choose, it lists 2 measuring systems here. This is really what it's doing. They installed the PP25. It's got this serial number on it, 13145. Okay, so I'm going to choose that one.
What is the other one?
The other one is just PP25 without a serial number with it. I think I'll probably go delete it so it doesn't confuse you after it's done. I didn't realize there were 2 in here. And then I'll click start. Okay, so now we're down at 1 millimeter. It's doing the same thing. If you focus on that screw, you can see it. It's kind of hard now because it's starting low, but it's just wiggling it back and forth. Right? It takes it about 30 seconds, maybe 40 seconds to run through this test. Okay, and then we'll click OK. There we go. So that was a moment of inertia.